Hi everyone. Today we're going to be talking about the difference between theoretical and experimental probability. So in section 10.6, we learned about theoretical probability, which is the probability based on what should happen when conducting an experiment. Now the experimental probability is the probability based on what actually happens when conducting that experiment. So for instance, we already talked about how the probability of flipping a coin and landing on heads is 1 out of 2, or 50%. However, when you actually conduct the experiment, so when you're actually flipping a coin a bunch of times, you most likely won't see heads and then tails and then heads and then tails and so on. So the experimental probability is, well, how many times did heads come up out of the total number of coin flips? So let's try this out with an example. So our table here shows the results of rolling a number cube. So we have all of these different outcomes rolling 1 through 6, and today we're going to be looking at the probability of rolling a 6. So first we're asked to find the theoretical probability. So this is like what we did the other day. So how many ways of rolling a 6 are there? There's 1 out of 6 total possibilities. So our probability is 1/6, or as a percentage, that is 16.7%. And now we're going to look for the experimental probability of rolling a 6. So first, we're going to have to figure out, well, how many total times did we roll this die? And we can figure that out by adding up all of the different frequencies. So these are the number of times each number was rolled. So if I add these all up, I'll find that we rolled the die 29 times. So out of those 29 rolls, how many of them landed on 6? And we can go to our table and see that there was a frequency of 6 times. So our probability is 6 out of 29, or as a percentage, this would be 20.7%. And then lastly, we're going to compare the experimental and the theoretical probabilities. So as we can see, they're not too far off. One was 16.7% and one was 20.7%. However, the experimental probability ended up being higher than the theoretical probability. So it was higher than what we would have expected it to be. Let's look at another example. So we can also use experimental or theoretical probability to predict future outcomes. So we can set up proportions like we've done in the past based on what we know. So let's look at this example. The table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Out of a similar group of 450 teens, predict how many would listen to music. So let's look. So we're told that the total is 200. So 200 teens were surveyed, and we're looking at listening to music. So let's look. Listen to music was 52. So 52 out of the 200 teens surveyed chose to listen to music. So this was music out of total. And we can set up a proportion. We're wondering, out of a total of 450 teens, how many would choose music? So here's my proportion, and now we have to keep going and solve it using our cross product property. And we will get 200x equals, let's see, 52 times 450 gives me 23,400. And I can divide both sides by 200. And we end up getting 104 teens chose music. Or we're predicting 104 teens would choose music. And one more example for today. So I'll have to make up these numbers since we're not in class. Let's say we have a class of 26 students, and we'll say 11 of those students made the shot into the recycling bin from the same line. All right, so what is the experimental probability that the next person will make it? So, well, we know that 11 out of 26 students have made it. So if I do 11 divided by 26, let's see, that's about 42.3% of students made the basket. So we're expecting that the next person has a 42.3% chance of making the basket. And now in the next part, again, we're going to have to set up a proportion. So we're told to use the experimental probability to predict how many students at Mathland Middle School, which has 630 students total, would make it in. So we can use our 11 out of 26 students that made it in and set up a proportion. So this was the amount that made the shot out of the total. And we're told that the total number of students is 630. So that's matching up with the total in the class, total in the school. And we're wondering, well, how many would make it? And now again, we will use our cross product property, and we will get an equation that says 26x equals, let's see what 11 times 630 is, 6,930. And I can divide both sides of the equation by 26 to get our prediction. And I end up getting 260, we'll round 267 students are predicted to make the shot. Now, this is just a prediction based on what has already happened in our class. So here are a couple examples on the difference between experimental and theoretical probability and using those probabilities to predict future outcomes.